If you've sipped clean water or enjoyed a soda, you've benefited from conductivity transmitters, even if you didn't know it. So, what's a conductivity transmitter? It's a small but mighty device that measures how well a liquid can carry electricity. Why does that matter? Because the more dissolved salts or chemicals in a liquid, the better it conducts electricity. In industries like water treatment, pharmaceuticals, food and beverage, and chemical processing, knowing exactly how conductive a solution is helps keep products safe and high quality. The transmitter uses a sensor dipped into the liquid. Imagine metal probes or a special cell. It tests the electrical flow, then converts that info into a standard output signal like 4 to 20 mA or a digital readout. That's easy for control systems to understand. This way, operators can monitor and adjust processes in real time. It's all about accuracy, safety, and efficiency. So next time you hear conductivity transmitter, picture a silent guardian, keeping things running smoothly. Have you ever followed a recipe, but something just didn't turn out right? Maybe the measurements were a little off. In science, getting our measurements exactly right is super important, and that's where calibration comes in. Think of a conductivity sensor as a special ruler that measures how well a liquid can conduct electricity. This tells us a lot about what's dissolved in the water, like salts or minerals. But just like a clock can slowly start to run a little fast or a little slow, a sensor can drift over time. Calibration is how we reset it and make sure its readings are true and trustworthy. It's the secret handshake between our tools and the real world, ensuring what they tell us is the actual story. Without proper calibration, the data we collect could be misleading. Imagine you're a scientist testing the water quality of a river. If your sensor isn't calibrated, it might tell you the water is perfectly clean when it's actually not, or it might raise a false alarm. This could have big consequences for the environment and for the people who rely on that water. Calibration isn't just a technical chore. It's a fundamental part of the scientific method. It builds our confidence in our results and allows other scientists to trust and even replicate our amazing discoveries. It's all about making sure our science is built on a solid foundation of accuracy, so we can explore the world with curiosity and certainty. So what exactly are we doing when we calibrate? We are essentially teaching our sensor what a specific, known value looks like. We use something called a standard solution, which is a special liquid with a precise, pre-measured conductivity level. By dipping our sensor into this solution, we can check if it's reading the correct number. If it's off, we adjust the sensor until it matches the standard. It's like tuning a guitar. You play a note and compare it to a tuner, then adjust the string until it's perfectly in tune. Calibrating our sensor ensures every measurement it takes afterward will be just as accurate and in tune with reality. This process is what separates guessing from knowing. It's a simple step that makes a world of difference in fields from environmental monitoring to food production, and even in laboratories creating new medicines. Every time you see a reliable piece of data about water purity or the contents of your favorite sports drink, you can be sure that a carefully calibrated sensor was behind it. It's a quiet but heroic task that empowers us to understand and interact with the world around us with incredible precision. So let's get ready to become calibration experts and unlock the full potential of our scientific tools. Before we can start our awesome calibration experiment, we need to gather our tools. Just like a chef lays out all their ingredients before they start cooking, a scientist needs to have everything ready. This makes the process smooth, fun, and most importantly, accurate. First and foremost, you will need your conductivity sensor, which is sometimes called a probe. This is the star of our show. It's the part that actually dips into the liquid and takes the measurement. Make sure it's clean and looks undamaged before you even begin. A little preparation now will save you a lot of trouble later on and ensure your results are top-notch. Next up, you'll need your meter. The meter is the brain of the operation. It's the device the sensor plugs into. It has a screen that displays the conductivity reading, usually in units like microsiemens per centimeter or millisiemens per centimeter. This is where you'll see the numbers and make the adjustments during calibration. You'll also need at least one, but preferably two, conductivity standard solutions. These are your reference points. They are special liquids that have a very precise, known conductivity value printed right on the bottle. Using a standard that is close to the conductivity you expect to measure in your samples will give you the best results. Don't forget the beakers. You'll need a few clean dry glass or plastic beakers. You'll use one for your standard solution and others for rinsing. It's super important that these beakers are spotless because any leftover residue from a previous experiment could contaminate your standard and throw off the entire calibration. We're aiming for precision here, so cleanliness is key. Along with beakers, you will need a supply of deionized or distilled water. This isn't just regular tap water. It's ultra-pure water that has had almost all of its minerals and ions removed, so it has very low conductivity. This makes it perfect for rinsing your sensor without leaving any residue behind. Finally, a few extra items will make your life easier and your calibration more professional. Grab some lint-free wipes or tissues for gently blotting the sensor dry between steps. You don't want to be rubbing it with a rough paper towel, which could scratch the delicate surface or leave behind tiny fibers. It's also a great idea to have a lab notebook and a pen ready to record your calibration data, like the date, the standard you used, and the sensor's performance. Being organized is the mark of a great scientist. With all your gear assembled, you're ready for the main event, calibrating your sensor. All right, it's time to get hands-on. Let's walk through the calibration process using our standard solutions. It's easier than it sounds, I promise. The first step is to wake everything up. Turn on your conductivity meter and connect the sensor probe securely. Let the meter warm up for a few minutes as the manufacturer suggests. This helps stabilize the electronics for a more reliable reading. While it's warming up, take a look at your sensor. Make sure the electrodes, the little metal parts at the bottom, are fully submerged when you place them in a liquid. You want to make sure the entire sensing area is covered to get an accurate measurement. Now let's get rinsing. This is a super important step. Pour some of your deionized water into a clean beaker. Dip the sensor into the water and gently swirl it around for about 30 seconds. This rinses off any dust or impurities that might have settled on it during storage. After rinsing, take the sensor out and gently blot it dry with a lint-free wipe. Never, ever wipe or scrub the electrodes themselves, as this can damage their special coating. Just a gentle dab on the outside of the probe body is all you need to remove the excess water droplets before moving on. Next, it's time to introduce the sensor to our standard solution. Pour a small amount of your chosen standard into a new clean beaker. It's good practice to pour just enough to cover the sensor's electrodes completely. Place the sensor into the standard solution and give it a gentle swirl to dislodge any tiny air bubbles that might be clinging to the electrodes. Air bubbles can interfere with the reading, so we want them gone. Now, put the meter into its calibration mode. Most meters have a button that says Cal or Calibrate. Follow the instructions on your meter's screen. It will guide you through the process. The meter will now read the conductivity of the standard. Wait for the reading on the screen to become stable and stop fluctuating. This might take a minute or two. Once the reading is steady, you'll use the meter's controls to adjust the displayed value until it matches the exact value of the standard solution, which is written on its bottle. For example, If you are using a 1413 microsiemens per centimeter standard, you will adjust the meter until it reads 1413. Once it matches, you confirm the calibration, usually by pressing the cal or enter button again. And that's it. You've just completed a 1-point calibration. For even better accuracy, you can repeat this process with a second standard solution of a different value. Congratulations! Your sensor is now a finely tuned scientific instrument. But the work doesn't stop here. To keep your measurements accurate for a long time, we need to talk about good sensor habits and knowing when it's time to recalibrate. First, let's talk about proper storage. When you're done with your measurements for the day, always rinse the sensor thoroughly with deionized water. This removes any leftover sample residue that could dry on the electrodes and affect future readings. After rinsing, some sensors should be stored dry, while others need to be kept moist. Always check your sensor's instruction manual to see what it recommends for happy, long-term storage. Proper handling is just as important as proper storage. The electrodes on a conductivity sensor are delicate and often coated with special materials like platinum black to increase their surface area and accuracy. That's why you should never touch them with your fingers or scrub them with a brush. The oils from your skin or the abrasion from a brush can damage this coating, leading to inaccurate readings. Always handle the probe by its body or cable. Think of it like a delicate piece of art. You want to admire it and use it carefully without ever touching the masterpiece itself. These simple handling rules will dramatically extend the life and reliability of your sensor. Now for the big question. How often should you recalibrate? The answer depends on how you use the sensor and how much accuracy you need. For really precise, critical work, like in a research lab, you should calibrate your sensor before every single use or at the beginning of each day. If you're doing general field monitoring, calibrating once a week or even once a month might be enough. A good rule of thumb is to recalibrate whenever you change the type of sample you're measuring, after you've stored the sensor for a long time, or if you ever get a reading that seems surprisingly high or low. Think of it as a regular health checkup for your sensor. Finally, while the standard solution method is the most common, it's cool to know there's another way called the cell constant method. The cell constant is a unique value for each specific probe that relates to its physical design. In this method, you don't adjust the meter's reading. Instead, you measure a standard solution and use the result to calculate and update the sensor's cell constant within the meter's settings. It's a bit more advanced, but is another powerful tool in the